Hi, Michael Canellis at ECOC 2025 in Copenhagen. I'm here with Matt Cisak of Lumentum, and we're talking about TRO modules. We have our Aura DSP. It's a 1.6 DSP made on 3 nanometer, running in TRO mode. And Matt, what is TRO mode?
Well, I guess first of all, Michael, thanks so much for coming.
Oh, hey,
to
thank
the
you.
booth. It's great to see you. Thanks for your partnership, as always.
Oh, yeah.
Great to have you back.
Thank you.
So TRO mode, that stands for Transmit Retimed Optics. And basically the idea of TRO is to save power. The way that it works is instead of having a DSP, which will retime the interfaces coming off of the module at both the transmit and receive side, now you're only retiming the transmit side, which saves a lot of power because you don't need to use all that power on the receiver side of the pluggable optic.
So what's the power drop to?
So power can go as low as 16 watts. So if you compare that to a normal pluggable 1.6T fully retimed transceiver,
20, 25.
right, it can be anywhere between 20 and 25 watts. So this is a significant savings compared to the standard pluggable use case.
Okay, excellent. Now, where would you use this? Wouldn't be, I mean, because regular DSPs, that can be 10 kilometers, 6 kilometers. You probably don't want to use a TRO with that, or it may not be optimal.
Right. So DSPs are everywhere in the data center. Obviously, they're part of critical infrastructure all over the place. In this particular use case, this is used typically in a connection between a NIC, which is a standard network interface card, to a first line switch. And the reason why that's interesting is because at a network interface card, the signal integrity is a little bit easier to manage than at the switch. So it can go straight from the transceiver all the way to the NIC chip which sits on that card.
Inside the rack, and there can be millions of those in a data center, right? There's
Millions and millions. I mean, these GPU build-outs are absolutely insane in terms of the number of accelerators that people are trying to put into a data center.
Okay. Let's take a look at the, if we could, on the board here. So we got, it's the Lumentum demo boards, classic configuration, and walk us through. What do we have?
So, what we have here are 2 transmit retimed optics evaluation boards. You can see the pluggable optics that are here. There's one pluggable optic here, one pluggable optic here. Underneath these heat sinks, these are the Aura DSPs. Basically, the signal comes from the board through the DSP, out the optics, back through the other side. And then, of course, because it's transmit retimed, there's no retiming on the receiver side. So that will go all the way back, and then the error checking will be done after the DSP.
Excellent. Now, one thing, it seems like every year I come to ECOC, there's like a new link. Like a few years ago, LPO showed up, right? And then, transmit retimed. It was like, I think it was about a year ago, people started talking about it. There's coherent lights coming out. Some never make it past the PowerPoint stage, but some are actually going to commercial deployment. Are we going to see more and more and more of this sort of diversity?
Yeah, absolutely. I mean, it's all about power. People are constantly looking for ways to save power. So things like not just transmit retimed optics, but linear pluggable optics. Coherent light is another great example where people are trying to reduce some of the functionality which is associated with coherent so that they can save power.
More bandwidth, less power.
More bandwidth, less power. All about power.
Excellent. Well, thank you very much, and thank you.